Now what happens is that whenever we are processing any data, so we will have some data, right? So we will have some data like this, where we will have some attributes, and let's say like this, and these attributes are A, B, C, D, E. Okay. Now, this we know that in any kind of system where we're dealing with data, we will have data like this. Now, in when we are talking about machine learning, we will have one extra thing in our data, that is, we should have a column. Let's call it a Y. Now, this Y is special because this is what we know as the independent variable. Okay. Sorry, not independent. This is what we know as the dependent variable. Okay. Now, dependent. Yeah, this is what we know as a dependent variable. Now, why it is dependent is because what we will always try to do in machine learning is that, okay, in machine learning also we have different types, where we have primarily three types. One is supervised learning, unsupervised learning, and reinforcement learning. What we are talking about is supervised learning. Supervised learning basically means that I will teach the computer how to make decisions, and then once I have finished my teaching the computer will make decisions on its own. So in supervised learning, what we have to do is that we have to have a dependent variable, the Y. Now, for the dependent variable, first for supervised learning, I will tell him what exactly this variable is all about. So for example, in our case, I will tell the variable for every row, what does the data represent? Okay, let's say in our case, we are detecting malware. So I will say that for these variables A, B, C, D, E, if the values are whatever the values are, this is a malware. So I will mark Y as 1. Now, if the values are something different, let's say these are the values. For these values, the Y is 0. 0 indicates that this is not a malware. This file does not contain a malware. And similarly, I will say the third record also does not contain a malware, and the fourth record maybe contains a malware, and so on. So I will have, let's say, 100,000 records, and for each of them, I will tell the software that this is the nature of data, where I have very clearly identified for you, this is the value of Y. This knowledge I have to give to the software, and then based on this knowledge, then the software will, what it will do is it will take the values of A, B, C, D, E and try to make a decision regarding which is a malware and which is not a malware. Now you would have understood that these columns A, B, C, D, E, these we are known as the independent variables. They do not depend on anything. Their values will decide what will be the value of the dependent variable Y. Now think of how you will do traditional programming. In traditional programming, what you will do is that supposing you had this data A, B, C, D, E, you would have written a logic which says if A is equal to something, what do you call, x, 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 then do this, do this, do this, and then you would say if B is equal to something, let's say y, 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 then you take another set of decisions, and you can also say B is equal to this and C is equal to Z, Z, Z. So you will write some logic like this. Am I correct? Right. So you will write a
Yes.
logic like this. So this is the way we do traditional programming. Now, the main difference between traditional programming and artificial intelligence is that we will not write any logic. So in traditional programming, what we do is that if you see this, if you make a generalization in traditional programming, what we do is we put data, we have data, and then we write the rules. So this if, then, else, or for, and all this kind of, these are nothing but the rules, right? So we write the rules, and these, when we submit the data plus rules, it gives us the output. So based on this if conditions, what we write, our program will say that, okay, fine. If I put the right kind of conditions, our program will say that under this circumstance, the file is a malware. Under this circumstance, the file is a good file. Right. So this is the traditional way of writing programs. Now in machine learning, what happens is that, or in artificial intelligence in general, what happens is that we do not write the rules. Instead, what we do is that we take the data, we will take the data and we will supply the output. This is the knowledge what we will supply to the computer, and based on this data and the output, the computer will formulate the rules. Now, the goodness of the artificial intelligence is determined by how good the rules are formulated by the computer, that the decisions what it makes are the best ones. So you got there's a paradigm shift between traditional programming and programming for artificial intelligence. Any questions so far? Okay.
Could you explain the second part, data plus output for gives the rules? Can you just repeat that?
Yeah, I will tell you. Let's see the same data what we have taken. Now you see what we are trying to do. Like I told you that I have got this data, right? If you notice, let's take a practical example. If you notice that we have got our malware files, right? We have got the files from Anand sir, right? Now for the files, we know that which files contain a malware and which files are good. So I have the value of Y for every file, correct? Now from each file, we will all extract certain variables which the file contains. So those variables will be part of the features, that is A, B, C, D, E, and maybe we'll have many more, maybe hundreds of them, right? So now all of this is also known to us, right? So we have, this is our data, this entire thing is our data, and this is the output also which is known to us. We are supplying the data and the output and telling the machine, you, based on this data and based on the output associated with each of the data items, you make your rules which you will use for determining whether how the output can be determined. Now, is it better? Clear?
So the rules is what is called model?
Rules is what is called the model. This okay. Rules, what it is, basically what the computer, I will now explain to you what the computer will do. So you will soon realize that what it is doing is nothing but creating some kind of a structure like this from the data. Okay. So it is also basically formulating some if then for else and etc. All that, but it is doing it on its own. You are not supplying that.
So it means that the data used in the second model, right? That is the historical data. Based on that, we are trying to arrive the rules.
Yes. See, what will happen is that this is the historical data, exactly what you have said, Santhil. This is the historical data, or in supervised learning, we have to provide data. Now, like you see how we are making the data. This is the traditional, this is the way anybody will do that. We have got the files are classified, which says these files are good files, these files have got a malware. So that knowledge is available to us. That knowledge we are supplying to the computer. Also, we are telling the computer that from these files, I have taken out this information regarding each file, and I am supplying that also to you. Take the case of, let's take another case. Let's say you have got to make a system which says whether a person is happy or not. How will you make that? So you will take the pictures of lots of people, maybe 1 million people's pictures you will take, right? Now you will feed all the pictures to the computer and tell the computer that this picture I've got this feature. Here the eye is like this, here the nose is like this, here the lips are like this, etc. And along with each of the attribute of each picture, you will say this picture is of a happy person. Similarly, you will take another picture and take out all the features from the picture and say this is the picture of a sad person. Like this, you have to create the data for all the 1 million data points that you have got, all the 1 million pictures you have got, and feed it to the computer. Once you feed that to the computer, then the computer will make the logic for determining how to determine whether a person is happy or whether a person is sad. Now, is it better?
Yeah, Partha, please proceed. Yeah.
Okay. So now what happens is that now with this primer, let us get down to some models that we will prepare. Now, uh,
Partha, maybe here I'm a bit confusing one point. Okay. So if we have a solid condition, for example, if the gate will open by 7 a.m. Okay, that is the existing model. But for this secondary model, right, the data we are providing, right, in the last 1 month, in that 1,000 employees, how many people are entered by 7 a.m.? How many people are entered into the 7:10 p.m.? So with that, we are trying to arrive the rule, and that rule is going to be implemented for future purpose.
yes.
Is it like that?
It is like that. Okay, now you have brought about one more point which I did not discuss, which I was trying to avoid. Nevertheless, let us discuss that. Now, in machine learning, we have got basically two type of problems. Okay, one is known as the regression problem. Regression, and one is known as classification. So this is known as classification. There is only two kinds of problems. Okay, now what we are discussing in our case, what applies is the classification problem. What we are trying to do is that we are trying to classify whether a file is good or contains malware. Okay, I have got, if you see our data, we have got only two characteristics for the JPEG files. The JPEG file contains either the JPEG file is good or it contains a malware. So there are only two classes possible, good or bad. Okay, but in the case of ELF files, if you notice the data what we have got data which says that these are good files and these are files which contain different kinds of malware. Some I forgot some kind. This is a Trojan or something. So there are different classes. I think 6 or 7 type of malware files what has been provided to us. So what we have is that we can, the ELF files, we can have two choices. Either we can say that the ELF file is good or contains a malware, or we can further say that ELF file is good or it contains a malware and the malware is of the type Trojan or ransomware, etc. Right? So in the ELF file case, what we have is called a multi-class classification problem. So we can create a model which will do multi-class classification, or we can do in the JPEG case, we can do a binary classification, right? So this is the problem in our hand. Now, one thing you notice automatically is that in the case of classification problem, the dependent variable is a what do you call, categorical variable, right? Categorical variable means these are discrete. It has got discrete values, 0 or 1 or 1, 2, 3, 4, 5. These are discrete values. But now the problem which you are talking about, Senthil, that how many people came between 7 to 7:30 or 9 to 9:30, etc. Here, my output variable is a continuous variable. It will be a number, maybe 10, 15, 20, 100, etc. This is a continuous variable, right? Maybe what do you call? So when we have a continuous variable and we are trying to create a machine learning model, those models are known as regression problems. Like for example, regression problem we can imagine as, let's say you want to predict what will be the temperature in Chennai tomorrow. So that is a regression problem. That is not a classification problem. Here the value is a continuous variable. The dependent variable is a continuous variable. Or you want to predict how many cases of coronavirus will happen tomorrow or maybe 10 days from now. That is a regression problem. That is not a classification problem. Does that clarify?
Yes, Partha. Thank you.
Yeah. So now let us come down to the kind of models that we will prepare. I told you I will start my discussion with the models. Now let's say we have this data with us. That is this data what I just told you. Based on this, there is one kind of model which we can prepare, which is known as the decision trees. Okay, these are very powerful models. These are known as decision trees. Now in decision trees, what happens is that I feed the data and the output, and the machine will try to create a model which says I will make a decision based on which, let's say it finds out that if A is greater than, let's say, 10, this is just arbitrary, okay, A greater than 10, then take this path, else take this path. Okay, further it will say that it will create a rule saying that if C is less than 5, take this path or take this path. And here it will make a rule which says if E is greater than 50, then take this path or this path. So like this, it will form a tree. The tree can go on, and in the end, what it will do is it will have a decision. This decision could be it's a malware, and here the decision could be it's benign. Got it? So this is a kind of model which the computer can prepare, which are known as decision trees. Now, is it clear? I have any questions here? Okay, I understand it's clear. Okay. Now, once the computer makes a decision tree, the decision trees have got a problem that what it will do is that the data what we give him, it will create a model which is very close to the data. Okay. If you notice that he's creating rules, which is made, these rules are created from the data which I have given him, right? So generally what happens is that the decision trees have a problem which we know as the overfitting problem. Okay, overfitting, in a simple terms, if you want to understand, it basically means that the model will predict very well on the training data, but when you give him the actual data, it will not be able to make good predictions. This is what is the overfitting problem. Okay, now decision trees have got a problem that they will generally, not always, generally they will cause overfitting. So what scientists made another algorithm where I will take a new sheet. Okay, now so scientists created a new kind of a model which is known as a bagging model. Now in bagging model, what we do is that we have the same data. On this same data, what they will do is that let's say this is my complete data set. So what they will do is that they will break this data set into multiple parts. Okay. Now each of the parts, the data what is contained here is taken random. It is not that I am just taking 1 to 100 line is so and so, and 201 to 200 is so and so. Not like that. I will take the data in each of the sets randomly. This is very important. If the data is not random, then our model will not be good. This is the underlying funda regarding anything that we do. Wherever statistics is involved, one of the things to remember is that statistics behaves good only when randomness is good. If randomness is lost, then anything we do with statistics will not be working properly. Okay, so what we do is that we take our complete data and we break the data into multiple chunks like this. Okay, then what we will do is that on each of the chunk we will make one decision tree. Okay, so we make one decision tree on chunk 1, then we make one decision tree on chunk 2, then we make one decision tree on chunk 3, and let's say in our case we have got 4 chunks, so we'll make a decision tree on chunk 4. So now each of the decision trees will be a tree, right? Like we discussed, it will be a tree like this. It will contain a model like this. Now based on this model, it will reach a decision like either it is malware or it is benign. So now everyone will have these models. What bagging will do is that it will run the data on each of the decision tree, and it will arrive at a decision in the end. It has to come to one decision only. It will take that decision and then find the mean of that decision. Okay. Now, what does it mean? Now, this can be confused. Now, if you notice that we have got two type of variables because of which we have two type of problems. One is continuous variable for which we have regression problem. One is classification problem where the variable is discrete. Now, if it is a continuous variable, it is very easy. I can take the value of the temperature in Chennai tomorrow from this model, from this model, from this model, and from this model, and I can find the average of these four numbers and say, tomorrow Chennai's temperature will be so and so. This is simple, right, to understand. In the case of classification, what happens is that when the value is discrete, what happens is that this model will make a prediction. Let's say the file is malign, and this also will say that file is a malware. This will also say that the file is a malware, and this will say that the file is benign. Now, here when it takes the average, it will say that majority of the models are saying the file contains a malware. So the ultimate decision is that the file contains a malware. Now you will definitely find that if there is a equal chance from all the decision trees, then what happens? There are rule breakers which can help in making a decision under these circumstances. But I gave you a general idea regarding what is bagging all about. Now, the main advantage of bagging is that it reduces the overfitting problem quite a lot. Not fully, but quite a lot, because each of the decision tree works on a different set of data, and that is why there are multiple models working for you, and these models put together give you the final decision. Now, another thing to understand is that important term to understand is, since there are multiple models working to make a decision for you, these kind of models are known as ensembles. Okay. Got it? Any questions? No question. I hope you're all there. Please respond.
Yeah, yes, Partha, we are here. Yeah.
Okay. Okay, now with this background, let us come to the model that we are planning to first make. That first model we are trying to make is a model known as random forest. Now, this model, why I am suggesting, is because this is a model which has got very few weaknesses. Like you see, so far we said that the decision tree model has got a weakness regarding overfitting. Bagging rectifies it, but not fully. Bagging also has got the same problem where overfitting can happen. So that's why we go for random forest. What is random forest is that now what happens is that, now look at bagging. What we did was we took chunks of data from our data set and we created multiple models for that. In random forest, what we do is that we also break the data vertically. That means to say what? I will take at random some number of columns. This is not that I will take first, second, third and all. I will take at random, maybe first, fifth and seventh column. And I will say that these columns will only form the part, this set of columns will form the part of my first decision tree. And the second set will form the part of my second decision tree. Okay. Now, why are we doing this? What is happening is that if I give all my variables to a decision tree, again, what will happen is that it will take all the values and try to form a model, right? So it will tend to overfit. So one of the techniques what we have in machine learning is called dropout. Dropout basically means that I will try to hide some data from the machine while training it, so that it does not see all the data. So if it cannot see all the data, it cannot make all the guesses regarding what the data can be. So that under that circumstance, the machine tries to make models which are much better. in terms of predicting on unknown data, because it has to always predict on unknown data. It will never predict on known data. If I know something, there's no point in making predictions on that, right? So what we do is that we hide some data from each of the models. So how do we hide? I will show him only few columns. I will show him only few columns and tell him that based on these few columns, you make your model. So each of the decision tree will see only few columns, and then it will try to make a model. Then the process is the same. Each decision tree will make the model, and ultimately we will do the mean of all the results, and we will come to the conclusion what this prediction should be. Got it? So this is what is random forest. Now random forest is very powerful, very popular, and very widely used. Okay. So one of the models we will prepare is a random forest model. Another model what I am proposing that we will prepare, like we have stated in our paper also, is that what we have is we have all our input files, right? So these are all, let's say these are all our input files. These input files contain either good files or files with malware. Now what we will do is that we will create some nodes. These are known as neurons. Okay, we will create some nodes. These are known as neurons, and we will feed all our files to these neurons. Okay, all the files we will feed to these neurons. Then we will decide. We may decide that we will create another set of neurons, and the output from the first neuron will go to the second layer of neurons. So like this, we will create a network. Ultimately, we will have one neuron. Let's say in the case of binary classification, this neuron will tell me only two things, either a 0 for a good file or a good file or a 1 for a bad file. Okay. Now, this is what we will try to create. This is nothing but what is known as the neural networks. This is by far the most advanced. I will give you a small idea regarding how this neural networks is created. It will take a lot of time to go into details of this. So I will give you a small idea regarding how this works. Maybe we can have more discussions and discuss this. So what is happening basically is that I am giving him all the input, right? This is my input. I already know that what is a good file, what is a bad file. Then I'm making these neurons. So these good files, these features are going to this neuron. This neuron, what it will do is that it will try to extract some data from this. We have to tell him how to extract the data. There are techniques for doing that. It will extract some data, and then it will pass it on to the next neuron. Then based on the extraction, what it has done, this neuron will make a decision that this is a good file or a bad file, right? Once the decision it has reached, that each path will make a decision whether it's a good file or a bad file. Once it has made a decision, it will then, when it goes in this direction, it is known as forward propagation. Okay, so it will make a decision whether, according to him, whether it's a good file or bad file. After he's made the decision, it will go backwards around the neural network, and it will go and check with the input whether the decision what he made was correct or not. If the decision was correct, it will keep its decision. If the decision was not correct, then it will again traverse in the forward direction and try to make a decision whether it's a good file or a bad file. You got me? So this is known as the backward propagation. So now it will do this multiple number of times. The number of times it does the forward and backward propagation is known as the epochs. So based on number of times it keeps on going back and forth. It will find out whether it's making a correct decision or not, and ultimately it will say that I am good as a model up to maybe 95% or 70%. I am able to make 70% good decisions, or I am able to make 95% good decisions. That will be the strength of your model. Is it clear?
Yeah, Pathak. Yeah, good.